Well, there's your problem. Damn, boy.
He's thick.
He's fucked. Yep. So now we've discussed the plunge depths and your mum. Yeah. Donny, Donington. So it was all going well up until a point. It stopped going well. Bit of a difficult day really, and the first major issue we've had with the car, and you know that can ruin your motivation a lot of the time, especially with the amount of time and effort and late nights that you pour into your car. But the key thing is to not let it knock you down and just get back up again. So in true GizFab vlog tradition, we're going to do a debrief. We're going to go over the car, what went wrong, what can we improve for next time. But I think in this episode, we're going to try and diagnose the engine at least. So at least we've got some closure on what happened to the engine. And then there's a few other things we need to talk about the car as well. Now, we're not going to start with the engine because that's the most obvious thing. We know it doesn't work. So I want to know why, but there's other things we need to look at first, and if I'm going to do that, I might as well take the engine out, so we'll deal with that last. So, positives, let's start with the positives, always start with the positives, is the rear brake caliper conversion worked absolutely mint, worked flawlessly, really happy with how it performed, so happy that I've actually ordered, I believe, 10 kits, and they'll be available on my website in a couple of weeks once you start to compile different variations of the kit. But yeah, rear brakes, really happy with how they worked out. They actually work too well. And what I mean by too well is that they lock up really easy, which you could say is a bad thing, but you need to remember is that we've removed our prop valve, which governs how much fluid is sent to the rear when you put your foot on the brake pedal. Which is why we installed the manual bypass valve, so we can slowly tweak the setting to the rear, and I've got it to a point now where it works really well. The issue is, I dare say, in the front brakes, it's probably more of a human error more than a component error, is that again the front brakes worked too well as well. Obviously we've got no ABS, so that could be part of it, but it did lock up a couple of times at Donington, and I've got no way of controlling the pressure to the front brake, so that's probably just going to have to be a learning curve. I'm sure over time we'll learn how that brake pedal reacts to input, and then we'll stop locking up the brakes and chewing through tyres. I'm pleased to say that the splitter and the air dam came back in one piece. And the one time that we had to remove the bumper when we was trying to diagnose the engine, it came off really well. The only thing that I'm not happy with is that the bracket on the driver's side has come loose, so I may need to look at replacing them bolts, some slightly longer ones, and maybe putting a bit of thread lock in there as well for good measure. So the next thing is, if you remember, we tubbed this arch because there was evidence of the tyre striking the inner wheel tub. That was a certain, definitely evidence there, definitely rubber laid down on the inside of that, but that didn't fix our vibration issue, and I have got a sneaky suspicion of what the issue is, so we're going to investigate that now. So I concluded that after the vibration was still there, and the vibration came really apparent on the very first corner, on the outlap of the first session. Unfortunately, we can't sort of get them sort of lows driving around the industrial state, which is why I have not felt it previously. But I've come to the conclusion that this drive shaft is too long. Now, I actually made a video of me making the drive shafts and sort of like showing up my mocking up process. Unfortunately, I just lost half the footage, so that video never came to fruition. But where I think the issue lies is that I measured the drive shafts at the old ride height. So before we load it, you know, 60-70mm to its current epic looking ride height. And I think what that has done is that it's messed with the plunge depths in the inner CV. So I aimed for a 10mm plunge. So in fact, it's probably best for me to demonstrate what the plunge depth is. So when this wheel goes up and down and the suspension moves up and down, this drive shaft will move in and out of the inner CV cup. Now, it won't move in and out of the outer CV cup because it's circlipped in there. But you can sort of see we do have a bit of movement, and that's the movement purely the outer CV circlip retaining groove. So let me just undo both of these with the buzz gun, and then I can demonstrate the plunge depth. Right, so now we've got both of the hub nuts out, which will allow the outer CV to be free, and then should give us a good demonstration of the plunge depth of the inner CV. So hopefully you can see in the video, I've sort of propped up the torch. So now what happens is if I pull the drive shaft, we have this movement just here where my finger is, and basically that movement equates to the movement we've got in the inner CV. Now, I've already measured the side, and we've got about 8mm of plunge. So we've lost 2mm by lowering the car, but that is the longer shaft. Now, come over to the passenger side, the sides that we've got the horrendous vibration on. And again, same sort of area where my finger is. And that's it. That's all the plunge we've got. So when you come this side, that's what that movement looks like. Now, I've already measured it off camera, and that side's got 2mm. So we've lost 2mm of plunge on the driver's side, but we've lost 8mm of plunge on the passenger side. And what I'm thinking is happening is that because they've lost that amount of plunge depth on this side, worth noting that this side is also the shorter shaft of the two. Maybe that's got something to do with why that side's only lost 2mm and this side's lost 8mm of plunge. So I think under high grip right hand corners is that the whole system is binding up because, you know, the shaft's bottoming out in the CV cup. Now, I have not actually stripped the shaft off yet. I'm not going to in this video for reasons. But without sort of looking inside of there, we're not going to sort of really see the extent of the issues / damage, if any. Now, I've already spoke with Satchels, because that's where I got the shafts from. It's not their fault, it's my fault. I checked the dimensions when they first come, and they matched what I asked them to make. So, unfortunately, they cannot make us a shaft for about 6 or 8 weeks, which at this time takes us past the last round at Snetterton. So what I'm going to do, which is going to pain me to do because those shafts were expensive, is we are going to cut them in half, and then we're going to shorten them by about 8mm. So we've got our plunge depths fine. Bit of a kick in the teeth, expensive fuck up, but it is what it is. So now we've discussed the plunge depths and your mum, let's have a look at the engine. So now we'll tackle the question of what the fuck happened to the engine. So engine was going absolutely mint. On the first session, Paul put us on a 12 psi map, and it had a very soft boost curve, so it came onto boost pretty much straight away, then plateaued. I didn't like that because the car felt very sluggish once you'd reached full boost. So in the second session, Paul had put me on a different sort of boost map. So this time we was targeting 16 psi, but the boost map was very linear to the RPMs. So I wasn't reaching full boost until right at the end of the rev range, which felt a bit better. In that session, the wideband yeeted itself, and the air intake temperature sensor also decided to go on the fritz. And then 7 laps in on that session, I went from 3rd to 2nd rather than 3rd to 4th, the old money shift. Now the Haltech data log showed that we had revved the engine to 9,800 RPMs. Now that's not the first time I've done that to this engine. I've actually money shifted this engine 4 times in total. If you remember the old shifter issues we had at Brands Hatch. But after the money shift, I could hear a vibration or rattling come from the engine. Now oil pressure was showing fine. I could hear the engine was on 4 cylinders, so I was kind of happy that the engine wasn't hurt. We got back to the pits, and after a static rev in the pits, you could hear this really concerning racket, vibration, distortion, whatever we'll call it. And after doing sort of like the old stethoscope with a screwdriver, we concluded that it was coming from the flywheel and clutch area down here. And naturally, I said to Paul, we're here, paid our money. There's only one thing which is going to fix this engine, and that is more boost. So we went on a 20 psi really aggressive boost map, and unfortunately we didn't even get around the outlap. We literally exited the pits, and you can actually hear in the vlog, you can actually hear it rattling. And then when I go from 4th to 3rd to downshift to start going down Starkey straight, you can hear the noise just disappears. So I pulled off. We got Ubered back to the pits, and we spent an hour and a half doing diagnostics on the engine. Now time was at the essence, so I didn't film any of it, but this weird thing happens with the engine, right? So you'll start it on the starter and it will spin over 5-6 times and it will just lock up. Engine will just lock up. So get a socket and ratchet on the crank pulley. Can't rotate the engine, even with a breaker bar, can't rotate the engine. But if you rotate the engine backwards, it frees up. Then once it frees up, you can actually rotate the engine again the right way. So we went through about half hour of start the engine on the starter, it locking up, rewind the engine backwards half a turn, on the starter again, 6, 7, 8 rotations, locks up again, rotate the engine backwards, frees up again, press the starter button, rinse, repeat. That happened for about an hour and it really baffled us. We plugged in the Haltech and the Haltech was giving an error of both the crank and the cam position sensors, synchronization error. So once we saw that, there's no real easy way to check it on these engines, unfortunately. Obviously we rely on the sensor of the data to tell us the position of the engine, and I think at this point we had 20 minutes to go. So taking the engine apart to check the cam chain timing just wasn't an issue, because this engine is a timing chain, not a timing belt. So we just kind of left it there really, pulled it back to the shop. Now I have played with the engine since it's been here. Same trick again, is you rotate it backwards, it frees up. You rotate it by hand 5-6 times, locks up. Rotate it backwards, rinse and repeat. So something really bizarre is going on inside this engine, and we are going to find out. So at first glance, we've got the keyway pointing up, our TDC marks about where they need to be, and then both cams seem to be lined up with their associated timing marks. So, little compression test next. See if that gives us any more clues. Yep. Right, so the plot thickens. We've got compression across the board. 5 psi difference, 185, 190, 185, 190. Originally I thought it may be the clutch, but if you just sort of turn it over, Luke. Fingers. Now I thought that was the clutch, but now the rocker cover's off, it almost sounds like it's coming from inside the engine. So I've got a sneaky suspicion that we may have thrown the crank trigger wheel off the flywheel. Now it's not going to take long to do that, so I think before we shut up shop tonight, I'm going to take the sump off and have a quick look. Well, now the sump is off, all is revealed. So I'm not sure how well you'll be able to pick up in this camera, but you see that hole, you see just here, there should be a bolt through there. So I'm guessing if we had took the crank sensor off, as we was thinking of, we may have seen the sensor damage. So basically we have sheared the crank trigger wheel off the crank. That would explain why the noise sounded like it was coming from the gearbox end, which sort of made us think it was possibly clutch related. But yeah, that is our problem. We have sheared the crank trigger wheel off the crank. And just to give you an idea of what's supposed to be happening in that engine is, this is the crank trigger wheel, and as you can see we have 1 and 2 here, and obviously these bolt heads have sheared off, so this plate is no longer bolted to the crank, it's fallen off. And that noise we were hearing is this plate being trapped between the crank and the crank girdle. So luckily we've got this little spare engine here. This is the dead 1.6, by the way, the very first engine that we bought. So my task is now is to remove one of these bolts, which luckily we can do quite easily, and see if there's any stronger option for the bolts that we can put in the replacement engine that we're going to put in that next week. Right, so a bit of a jump cut with engines sort of back together. Had a car show at Yakushi this weekend, so even though the car didn't run, I took it as a static display. Yeah, we've somehow sheared the crank trigger wheel off the crank. Not quite sure how we've done that, but maybe the money shifts is something to do with that, and maybe some of the vibration which is being transferred through this drive shaft issue here probably hasn't helped the situation either. Now I'm not sure what I showed in those last couple of clips, but the sump had a lot of metal filings in it, so I'm gonna pretty much write this engine off. It's done as well, but with that amount of metal in the sump, I don't really want a chance trying to fix a crank trigger wheel and not to get anywhere with it. So unfortunately we can't get in there to look exactly what's happened, because we've physically got to take the crank out to look at the trigger wheel. So, but luckily we've got the old 1.6 that was destined to failure all the months ago, and as you can see I've already sort of been playing with this one. So this is the crank trigger wheel, not sure how you can see there, but basically the trigger wheel is held on by these tiny, pathetic internal drive Torx headed M6 bolts. Now they have that pathetic small head because there is zero clearance in between the trigger wheel and the side of the engine casing where like the crank seal and that goes. But you can actually see that the trigger wheel has a indent there for the bolt to sit in. Now I don't think there's much we can do about that. We can maybe get a special bolt made, but I doubt no one's going to want to make 3 special bolts, especially ARP. I've looked for the catalogue, they don't seem to have anything suitable like that, but I have had a few people message me and say that on some vehicles they actually weld the bolts to the trigger wheel. Now luckily we can get in there with a TIG torch if we need to, but I think we've just got to count ourselves lucky, because a money shift on any engine is pretty much fatal, and to do it 4 times and get away with it 4 times, I think that's pretty good going. So I'm not sure what to do, other than obviously this engine's got to come out, it's dead. Worryingly, we actually can't find the heads of the bolts. Other than that, I'm not quite sure what's actually happened. I'm not sure if the trigger wheel's actually sheared off the bolts, or if the bolts have started to back out and the head's been caught by the inside of the crank and that's sheared the bolts of the head off, and that's why it's walked off the remaining threads. Now the threads are still in the crank. I'm not sure if I showed that in the video, but all 3 threads are still clearly in the crank. Bit of an odd one, but at least we've got down to the bottom of the issue and we've found a potential weak point with this engine. Now at the time of recording this video, I have 2 engines on their way to me after an arsehole of a breaker on eBay waited a week and a half to tell me that they didn't have the engine in stock. So that really made me happy. But luckily I've got an awesome group of friends on Facebook, and because of everyone on Facebook, I have 2 engines on the way. I've got a full car coming tomorrow, a full running and driving 1.5 Micra, and on Friday I've actually got a bare engine being delivered to me all the way from North Wales. Then that gives us 2 engines, 1 to put in, 1 spare. Now we have still got the 1.5 down there that we bought to build, but by the time I bought a head gasket, head bolts, everything, it's just not going to be worth it. We're going to take the engine out this week, and Saturday we can put a new engine in and then hopefully get it running the same day, if not Sunday, because a week on Saturday we have been luckily accepted into the Quick 60 Hill Climb Monsters event at Mallory Park as part of the Retro Rides gathering, so really looking forward to that. So yeah, we're going to be at the Quick 60 sprint event on the Saturday, and then on Sunday the car will be on Artek's stand, at which you can come and look at all the fabrication work that we've done on this car, all done and welded up using Artek welding machines, and hopefully on Sunday as well, if we get accepted for some track time. If you don't come on a Saturday, you'll be able to see us boosting around at least on the Sunday. So before I go, don't forget to like, share, comment, subscribe with all your homies. And with that being said, we will see you in the next video. Bye for now.